The brain gets much of its thinking power from a class of electrically excitable nerve cells known as neurons. Our brains have over 100 billion of them, but they don't work alone. They're team players. What makes neurons so powerful is their ability to connect with other neurons. These connections form a massive web of electrochemical pathways that is the home of the cognitive phenomenon that scientists call the Heloec shiznit that happens inside your bristle. When neurons connect, their terminal endings get close to each other, but they don't actually touch. They are separated by a 4-nanometer expanse called a synapse. To understand how synapses work, we'll need to pull one apart. No, that's too far. Let's bring it back in a bit so we can see how neurotransmitters manage to leap across this expanse. Neurons don't just fire randomly. They must be triggered by an impulse that is strong enough to overcome the stimulus threshold. This protects the brain from responding to weak or insignificant signals. Only very powerful impulses make it over this threshold. And this keeps our brains from being distracted by forms of stimuli that are either unimportant, trivial, or just downright wimpy. To win at this game, a stimulus must really pack a wallop. But when an impulse does make it over this threshold, it sets in motion a chain reaction of neural activity that can reach across the entire expanse of the brain. Neurons aren't the only things that can communicate without any actual contact. This is increasingly true of how our brains communicate with other brains. Humans can now easily communicate with thousands of others without ever having to come into contact with any of them. This ever-widening social synapse is one of the greatest contributions to the contemporary lifestyle since walls.